All right, let's get started with our notes for today. We're going to look at domain, range, and evaluating functions. Really, in order to understand a function, we got to start with the basics, and that starts with a relation. Simply, a relation is a set of ordered pairs. So if I ask you to plot the point 5, 2, I'm going to go along the x-axis to the right 5 and up the y-axis 2. Ordered pairs, 5, 2. That is a relation. Now, the relation can be represented in the form of a table, a graph, or even a mapping diagram. All three of these forms have been represented below. Keep in mind that when we're referring to the domain, that is all of your x values. The range is all your y values. So in these examples below, it says find the domain and range of each. In the first one, we have a table. You can see that x corresponds to 3, 4, 5, 6. Y corresponds to 1, 2, 2, 3. Now, anytime you're listing out domain and range of individual points, we're going to use curly braces and list out each of those x and y values respectively using commas. If there are any values that are repeated, we're only going to count them once. So as you can see here in that second row for the y values, 2 gets repeated twice. We're not going to list it twice in the range. We'll just simply write that 2 is part of the range. On the diagram below, we have a mapping. The left side is your input, that's your x values, and it draws an arrow to the right side, which is going to be your output values, which is going to represent your range. Now, when we list out our domain and range, we typically like to write them in numerical order. So I know that my domain is 7520, but let's go ahead and write that starting with 0 to 5, 7. All right, now our range was in numerical order 3, 6, 7, 10. And then moving to the right side, when we're looking at a graph, for my domain, we always go left to right. So my first x value that exists in this function is going to be when an x value is at 2, right here. And then it continues to the right where every x value is included in the function until it stops at x equals 7. Now, rather than listing out every single x value individually, like 2, 3, 4, 5, 6, 7, we can abbreviate that by just using what's called set notation. Now, set notation usually uses inequalities. So to list out all my values between 2 and 7, I can use the inequality x is greater than or equal to 2 and less than or equal to 7. For my range, we're always going to go bottom to top. So the first y value that exists in this function is at y equals 3 and goes all the way up to y equals 5. So we could write that in set notation as y is greater than or equal to 3 and less than or equal to 5. Now, taking that understanding of a relation, let's apply it to a function. A function is a relation in which each element of the domain is paired with exactly one element of the range. What does that mean? Well, that's saying for every input value, I get exactly one output value. So if I had a mapping, let's say with the values 2 and 4, let's say 2 corresponded to 5, but 4 corresponded to 2 output values of, let's say, -3 and 1. That is not a function. Because based off this definition, for each input, there has to be exactly one output. Well, when I input 4, I get an output of 2 values, -3 and 1. That is not a function. So in the example down here below, you can see with this mapping, -3 corresponds to 5, 0 to 3, 2 to 2, 4 to -1. Each input has exactly one output. That is a function. Now, how do we test that with a graph? We can use what's called the vertical line test. And the vertical line test simply says that if I am to draw a vertical line through any part of the graph, it should only intersect that graph exactly one time for it to be a function. If it only hits one time, that tells us that our input only has exactly one output. So just to give you an example, in this graph here, if I draw a vertical line anywhere through that graph, it only intersects the graph one time. That is a function. All right, let's go through some practice. Domain and range. Number 1, it says state the domain and range given the following relation. So our x values are 0, -1, -4, and 9. Our y values are 2, 5, -7, -8. So again, these are individual points, so I'm going to list them out using the curly braces. Again, let's write this in numerical order. So -4 is first, -1, 0, 9. And then for our range, in numerical order, we have -8, -7, 2, 5. Number 2, we're given a table. Let's state our domain. We have -4, -2, 0, 3, 6, 7, 8. And then for our range, we have in numerical order -10, -5, -4, 4, 7, and 9. Now in number 3, we're given a graph. It says state the domain of and range of each of these graphs. So again, when I'm looking at a graph, I'm going to start with my domain. I'm going to go left to right. So moving from the left side to the right, I don't have an x value until x is equal to -4, and all the way till it stops at x equals 5. So how do we write that using set notation? We're going to say x is greater than or equal to -4 and less than or equal to 5. For my range, we're going to go from the bottom to the top. So first y value as I work my way up is right here at y equals -3, and it goes all the way to the top at y equals 6. So we're going to say y is greater than or equal to -3 and less than or equal to 6. Now in my next example, in this graph, our first x value is at 1, and it goes all the way till x is 6. However, at 1, you can see that we have an open circle. An open circle means that it's not included. So it's not particularly defined at x equals 1. There is no output value that corresponds. However, if it's filled in, obviously that is going to be included. So at 6, I get out -1. So for my domain, we're going to say it's all possible x values that are greater than 1. Again, we're not including 1, so it doesn't get the inequality of equal to, and it's less than or equal to 6. For our range, bottom to top, our first y value is at -5, and it goes all the way up till a y value of 1. Again, at 1, it's not included, so we'll make note of that. And it's bigger than or equal to -5, less than 1. For our last example, for our domain, we're going left to right. So notice this arrow is going on forever in that one direction. So every x value is included till I hit 1. Now at 1, you can see that there is a point included and a point that's not included. So if I ask you at x equals 1, is there an output value? The answer is yes, at 1. So 1 is included. And then everything after 1 till I get to 2. And again, at 2, I've asked myself, is there a point that's included? And the answer is yes at 3. So it goes on forever in both directions. So in this particular problem, although it may look like there's going to be some breaks in this, every single x value is included. So we can write this as all real numbers since every x value works. Now, the abbreviation for all real numbers looks like this, but you can just write out all real numbers if you want. And then for our range, let me just go ahead and erase this. When we're doing our range, we're going from bottom to top. No y values exist on our graph until I get to y is equal to 0. And then every point after is included in my range. So that tells us that our range is going to be all values of y that are bigger than or equal to 0. And finally, the last part of our notes for today, we're going to look at how to evaluate a function. And in order to evaluate functions, you need to know about a certain type of notation called function notation. So let's consider the example. Let's say we have an equation of y equals 3x minus 8. The only difference between that equation and function notation is you can see that function notation says f of x equals 3x minus 8, where the original equation was y equals 3x minus 8. Now, when you see f of x, that is your output, which is your y value. So y and f of x are the same. Now, the reason we need to learn function notation is because in a function, x represents the elements of the domain, f of x represents the elements of the range. So suppose you wanted to find the value in the range that corresponds to the element of 5 in your domain. How do we write that? Well, it's written using function notation. F of 5. F of 5 looks like this. And again, f of 5 is how it's read. Now, the value f of 5 is just simply found by substituting 5 in for x into the equation. Let's take a look at a few examples based off a graph. In number 4, it says, use the graph to evaluate each of the following. In part A, we have f of 5. So that's saying when x is 5, what is y? So when I plug 5 in, what do I get out? Well, based off the graph, when I plug 5 in, I get out 0. So we're just going to put 0. Letter B, f of negative 2. So when I plug negative 2 in for x, what do we get out for y? Well, when I plug negative 2 in based off the graph, we get out negative 2. When I plug 3 in, I get out 4. Now in D, it's a little different. Now we're going to work in reverse. It says find the value of x, so find your input so that your output f of x equals 0. Again, f of x is really y, so x so that y equals 0. So we got to find the x that corresponds to an output value for y of 0. Well, take a look at your graph, and you can see here that there are 2 places where you have a y value of 0. One at negative 1, and again, one again at 5. So we're going to list x out to be 2 values, negative 1, 5. Since f of negative 1 gives me 0, and f of 5 gives me 0. Letter E, find the values of x so that f of x is negative 5. So again, we're finding a value of x, so when I plug in something, I get out negative 5. Well, based on this graph, there are no values of the graph that are even contained with a y value of negative 5. So again, undefined. There are no x values that correspond to a y value of negative 5. Now for part F, it's asking us to list out our domain. So again, rather than listing out individual points or elements of our domain, we're going to go ahead and use our set notation. So from left to right, I know my first x value starts at negative 2, and negative 1, 0, 1, 2, 3 is included. And then it doesn't start again until 4, and then everything after 4 is included because that arrow again goes on forever. So we need to write this using set notation. So we're going to say that our x values range from being greater than or equal to negative 2 and less than or equal to 3. So again, that's our first part, from negative 2 to 3. And then, and x has to be greater than or equal to 4. For our range, again, working bottom to top, our first y value is at negative 2, and it includes every value all the way up to 4, but you can see this part of the graph also includes 4 and goes on forever. So our range is going to be all values of y that are greater than or equal to negative 2. All right, looking at number 5 here. Now we're using our table to evaluate the function. Find f of 2. So when I plug 2 in, I get out negative 1. When I plug in negative 6, I get out 10. And for C, it's saying find a value of x that gives me out 3. Well, that is 5. Last part, number 6. Now we're given 2 functions, f of x and h of x. For part A, we're finding f of 2. So I'm going to plug 2 in for x into that equation. And 3 times 2 is 6, minus 7. 6 minus 7 is negative 1. For part B, h of negative 4. So I'm plugging negative 4 into my function h. So h of negative 4 equals negative 4 squared minus negative 4 plus 3. Now notice when I'm plugging in these values for evaluating these functions, I'm always using parentheses around whatever it is that I'm plugging in for x. Super important, because if you start typing this all on your calculator, straightforward, the way you have it written without parentheses, you're going to get the wrong answer. So make sure you include parentheses. Negative 4 squared is positive 16. Minus a negative 4 is plus 4. Plus 3 is 23. Letter C, find f of 4a plus 1. So 3 times 4a plus 1 minus 7. We have to distribute. 3 times 4a is 12a plus 3 minus 7, which is 12a minus 4. H of a plus 3. Got to plug a plus 3 in for x. That's a plus 3 squared minus a plus 3 plus 3. Now, a plus 3 squared means write it twice. And then we'll distribute that minus sign. So minus a minus 3 plus 3. So we know the negative 3 and 3 cancel. Now, this first part, a plus 3 times a plus 3, we got to FOIL this. So FOIL, remember, is first, outside, inside, last. We get a squared plus 3a plus 3a is 6a plus 9 minus a is a squared plus 5a plus 9. And that's it.